Hi, welcome to pibyme Maths. This is Devan. In this video, we are going to solve January-February 2024 Pure Math 1 paper. In the previous video, we have covered question number 1 to 5. Let's look at question number 6. We have a function given. Show that the function f of x equals 0 has a root in this interval. So basically, you need to sub in the points into the function. But use your calculator in radian mode. X minus 4 minus cos 5 root of x. F of 3.5 is 3.5 minus 4 minus cos 5 root of 3.5. If there is a change of sign, that means there is a root. So 2.5 minus 4, wait, let me put the calculator in radian mode first. Minus cos 5 root of 2.5, bring the cursor outside and close the bracket. That's minus 1.44 minus 1.44 dot dot dot. It's a negative number, but sometimes for questions like this we might need the value in the later part, so I'm gonna store the value as a. Okay, and then for f of 3.5 minus 4 minus cos 5 square root of x. X is 3.5. Close the bracket. 497, 0.497 dot dot dot, which is positive. So you need to write the conclusion. There is a change of sign and f of x is continuous. That's how you write it. Therefore, f of x equals 0 has a root alpha in the interval. Just copy from the question. Interval 2.5, 3.5. That's all. It's a 2-mark question. Let's move on to part B. Yes, okay, we are using linear interpolation. We need the value of these two. So I'm gonna store this value as B now. Okay, we are gonna apply the linear interpolation. So let's say this is x-axis. Our 2.5 is here, 3.5 is here. The function value of f of 2.5 is negative, so it will be below the x-axis, right? And then so this is f of 2.5. Since it's a negative number, but the length of this line, it has to be positive, so I'm going to put another negative sign. So negative times negative positive, this will be the length of this line. And then here this value is positive, f of 3.5. So this length is f of 3.5, right? Draw a line here connecting these two. The alpha is right in the middle, in between these 2 points, not in the middle, in between these 2 points. So we are going to apply linear interpolation now using the similar triangle method. This length divided by this length, which is alpha minus 2.5 divided by 3.5 minus alpha, is equal to this length divided by this length, which is minus f of 2.5 divided by f of 3.5. Why I have taken minus f of 2.5? Because talking about length, f of 2.5 is a negative number. It's a negative number. So minus f of 2.5 is going to be a positive number. Now cross multiply, make alpha as a subject. So when you multiply these two, alpha times f of 3.5 minus 2.5 f of 3.5 is equal to, multiply these two. So 3 minus 3.5 f of 2.5 and negative times negative plus alpha f of 2.5. And then bring this term here and take alpha as a common factor out. You will get f of 3.5 minus f of 2.5 is equal to, move this term this side, you will get 2.5 f of 3.5 minus 3.5 f of 2.5. Therefore, alpha is equal to Now sub in the value of these functions. F of 3.5 is this 497, etc. So 2.5 times 0.497 dot 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 minus 3.5 times f of 2.5 is this minus 1.44 minus 1.44 dot 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 everything divided by, when you bring this whole thing to the other side, becomes the denominator, right? So it's f of 3.5, which is 0.497 dot 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 minus 1.44 dot dot. So when you put it in the calculator, it's very easy because we store the values a and b. The negative value is a, this value is b. So I'm going to simply put it in my calculator. 2.5 times b, 2.5 times b minus 3.5 times a divided by b minus a. You will straight away get the answer. Round it to 2 decimal place. So 3.24 is the answer. That's all. Part C now, part double I. Determine g dash of x. Okay, first of all, I'm going to write g of x as 1 over 10 x square minus 1 over 2 x power minus 2 plus x minus 11. So g dash of x is going to be 1 over 10 times 2x minus 1 over 2 minus 2x power minus 2 minus 1 plus 1. So it's going to be 1 over 5x, 2 will be cancelled, you'll get positive 1 over x cube plus 1. That's g dash of x, a 2-mark question. And the next part is Newton-Raphson method. The equation has a root in the interval 6, 7. Use x naught as 6 and find the second approximation. So this iterative formula is given in the data booklet. Xn minus f of xn divided by f dash of xn. So x1 is x naught minus f of x naught divided by f dash of x naught. The x naught is 6, so it's going to be 6 minus, sub in 6 into the function. It should be g actually, not f. G dash. So this is the function g. Where is it? G. Okay, this is the function g. In this function, replace x by 6. So it's going to be basically 6 square over 10 minus 1 over 2 times 6 square plus 6 minus 11. That's a numerator divided by denominator. Denominator is g dash. G dash is 1 over 5x, which is basically x over 5, plus 1 over x cube, 1 over 6 cube, plus 1. Just get the value to 3 decimal places. 6 minus 6 square 36 over 10 is 3.6 minus 1 over 2 times 36, which is 72, plus 6 minus 11 over 6 over 5 plus 1 over 6 cube plus 1. I want the answer to 3 decimal places, so 6.641 is the answer. That's all. Question number 7. The parabola C has this equation and the point lies on the parabola. Use calculus to show that the equation of the normal is this. So first we need to differentiate it. So y is equal to square root of 4 over square root of 3 times square root of x. When you differentiate it, 2 over root 3, x power half becomes half x power half minus 1. which is 1 over root 3 times root x. Sub in the x coordinate here to get the slope of the tangent. So slope of the tangent is equal to 1 over square root of 3. When you square root the x coordinate, it's going to be t over square root of 3. You will get 1 over t. So the slope of the normal will be, because normal is a perpendicular line to the tangent, so it's going to be a negative reciprocal of this, which is minus t. So you have a slope, you have a point, you can take the point as x1, y1 and write the equation y minus y1 2t over 3 is equal to slope times x minus x1. Now we need to write the equation in this format. Multiply through it by 3, you will get 3y minus 2t is equal to minus 3t times x minus t cube over 3. Open the bracket, you will get minus 3tx plus t power 4. So put 3tx this side, you will get 3tx plus 3y. Bring minus 2t to the other side. Sorry, this is t square and this will be t cube. So you will get t cube plus 2t. That's all. So 3 mark question. Part B. The normal to C at the point where t is equal to 9. Okay, we have the equation of the normal, which is 3tx plus 3y is equal to t cube plus 2t. When you replace t by 9, you're going to get 9 3s are 27x plus 3y is equal to 9 cube. Sorry, 9 cube plus 2 times 9. 747. Can divide through it by 3 actually. 9 3s are 27 plus y is equal to, this number divided by 3 is 249. Now that's the equation of the normal when t is equal to 9. So this meets the curve C again. The equation of the curve is y square is equal to 4 over 3x. So find the exact value. We need to solve this actually. From here we can find y 249 minus 9x. Sub in here. So 249 minus 9x the whole square is equal to 4 over 3x. Expand the bracket. A square, which is 249 square, 62001. 2ab, 2 times 249 times 9. 4482 minus 4482x plus b square 81x square is 4x over 3. Multiply through it by 3 and frame a quadratic equation and solve it. I'm going to multiply through it by 3 now. Okay, when we multiply through it by 3, 62001 times 3, 18600, 18600, minus 4482 times 3. Which is 13446, 13446. 81 times 3, 3 8s are 24, so 243. 243x square minus 4x is 0. Okay, we have this equation. I'm going to write it in the standard form. 243x square. There are two x terms. these two. Wait, there was an x here. Actually, I missed out x. There was an x here, so these two are the x terms. So it's going to be minus 13450x plus 18600, is equal to 0. I'm going to solve this straight away. Go to quadratic. 243 minus 13450. 1860003. Okay, 6889 over 6889 over 243. That's one value of x, and the other value will be 27. So you need to write this step. 243x minus 6889 times x minus 27 is equal to 0. So we need to find out which one is the x coordinate of the point we are trying to find out. Okay, go back to the question now. If x is 27, if t is 9, 9 square over 3 is 27. So the x coordinate 27 is basically the x coordinate of point P. So don't take 27, take this point. So x is equal to 6889 over 243. Now we need to find y using, we can use this equation. 249 minus 9x. Y is equal to 249 minus 9 times x. That would be the y coordinate. 249 minus 9 times 6889 over 243 minus 166 over 27. Now go back to the question. They say it's the point Q. So you can write therefore Q is 6889 over 243. That's the x coordinate, comma, minus 166 over 27. That's all. Question number 8. Use the standard result for summations to show that this is equal to this. So I'm going to take this sigma notation and open the bracket first. So it's going to be sigma 2r cube minus 3r square minus r. R is equal to 1 to n. And then split the sigma notation here. So 2 sigma r cube minus 3 sigma r square minus sigma r. Write the limits. And then look at your data booklet. There is a rule for sigma r cube. It's n square times n plus 1 whole square over 4. There is a rule for r square also, which is 1 over 6 n times n plus 1 times 2n plus 1. For r, actually, the rule is not given in the data booklet. It's same like this, but take it without the square. So n times n plus 1, the square root of 4 is 2. That's a rule for sigma r. Now we need to simplify this by taking out a common factor. First, cancel this, you will get 2. Cancel this, it's 2. We need 1 over 2 as a common factor. So I'm taking 1 over 2 n times n plus 1 as a common factor. So in the first term, when you take n times n plus 1, you'll be left with another n and another n plus 1. And in the second term, if you take n and n plus 1, you'll be left with just 2n plus 1. And in the third term, it will be just minus 1. Open the bracket and simplify, you'll get the answer already. Okay, they want us to prove this actually. So it's 1 over 2 n times n plus 1. You open the bracket, you'll get n square plus n. Here open the bracket, minus 2n minus 1 minus 1. So that's gonna be n times n plus 1 times n square minus n minus 2. And factorize the quadratic. It's n plus 1 times n minus 2, right? So you can combine and write it as n plus 1 whole square times n minus 2. That's what they want us to prove. That's all. Part B now. Hence show that for all positive integers n, this is same like the one given in part A. The only difference is the upper limit is 2n. So we are going to write this r is equal to 1 to 2n. R times 2r square minus 3r minus 1 is equal to, if it is n, actually we have proved it is equal to 1 over 2 n times n plus 1 whole square times n minus 1 in part A. So replace n by 2n now in the same result. But if you look at the lower limit, it's not 1 actually. If it is 1, just replace here n by 2n, right? Because the upper limit is 2n, but the lower limit has to be 1 actually. So we are going to split the sigma notation. This is not 1 to 2n, it's n to 2n. We are going to take it as 1 to 2n r times 2r square minus 3r minus 1 minus 1 to n minus 1. Hope you understand this term. We need basically, this is 1, this is n minus 1, n, 2n. We need from n to 2n. So we find 1 to 2n and subtract this part. So in the result, actual result, we are going to replace n by 2n. So 1 over 2 times 2n times 2n plus 1 whole square times 2n minus 1. In this result, replace n by the upper limit minus, replace n by this upper limit. Half times n becomes n minus 1. N plus 1 becomes n minus 1 plus 1 whole square. N minus 1 becomes n minus 1 minus 1. Just replace n by the upper limit and simplify it. So I'm not going to cancel 2 because we need 1 over 2 as a common factor. So keep it as it is. 1 over 2 times 2n times 2n plus 1 whole square times 2n minus 1. So in the part A result I made a mistake. It was n minus 2 actually. So it should be 2n minus 2. This was n minus 2 minus this. Minus half times n minus 1 times here minus 1 plus 1 cancel. You will get n squared times n minus 3. We need to simplify this 2 and write it in this format. So we need to write the answer in this format. So I'm going to take the last step now. Let's take out the common factor. Look for common factors. Okay, first of all, I'm going to take 1 over 2n as a common factor. So in the first term, I'll be left with 2n plus 1 whole square and 2n minus 2. I can take out 2 as a common factor and write it this way. Here I'll be left with minus 1 over 2n minus 1. There is only 1n and n minus 3. Right? Take again n minus 1 as a common factor. So now there won't be any half because we have taken half as a common factor. So half n times n minus 1 times 2 times 2, 4 times 2n plus 1 whole square minus n times n minus 3. Now just keep this as it is because we need n times n minus 1 in the final answer. Expand the bracket. A square plus 2ab plus b square minus n square plus 3n. So it's half n times n minus 1. When you open the bracket, you will get 16n square minus n square is going to be 15n square. 16n plus 3n is 19n plus 4. Factorize it, that's all. N times n minus 1. How to factorize it? Use your calculator. Go to quadratic. Type 15, 19, 4. Minus 4 over 15. And then the next number is minus 1. Write them as factors. So you will get n plus 1 and 15n plus 4. This looks exactly like this answer. That's all. Question number 9. Given that 3z minus 1 over 2 is this, where lambda is a real constant, determine z. Give your answer in the form of x plus iy. Okay. First we take this as lambda plus 5i over lambda minus 4. I multiply and divide by the conjugate of this. So you will get lambda square plus 5i lambda 4i lambda 9 lambda I 5i times this is 20 I square is minus 20 divided by lambda square plus 16. You will get minus 16 I square is negative 1, right? That's 3z minus 1 over 2, and then find z. So bring the 2 here. So z is basically this whole thing times 2 plus 1 divided by 3. So 2 lambda square plus 18 lambda I minus 40 over lambda square plus 16 when you multiply by 2 plus 1, that's 3z. Calculate this and then find z from here. So let's simplify this. If we combine this to a single fraction, you need to multiply this 1 by lambda square plus 16 by lambda square plus 16. So you're going to get 2 lambda square plus lambda square is 3 lambda square plus 18 lambda I minus 40 plus 16 is minus 24 divided by a common denominator lambda square plus 16, but take 3 here, this 3 to the denominator. So this is the last step. Let me copy it here. That's z is equal to. So in the denominator you can take out 3 as a common factor and cancel with 3 in the denominator. So you'll get lambda square plus 6 lambda I minus 8 divided by lambda square plus 16. So write the real and the imaginary part separately. Real part is lambda square minus 8 divided by this, plus imaginary part is 6 lambda over lambda square plus 16i. That's all. Part B. Given also that argument of this complex number z, this complex number is pi over 4. If it's pi over 4 in the organ diagram, the argument will be here, right on the line y is equal to x. That's why the argument is pi over 4. In other words, the x coordinate and y coordinate of the point will be equal. So you take the real part, equate it to imaginary part. The real part of z is lambda square minus 8 over lambda square plus 16 is equal to 6 lambda over lambda square plus 16. You cancel this, put 6 lambda this side, lambda square minus 6 lambda minus 8 is 0. And then you need to solve for lambda. Lambda is minus b plus or minus square root of b square minus 4ac everything divided by 2a. So go to quadratic. 1 minus 6 minus 8, 3 plus or minus square root of 7, 3 plus or minus square root of 17. Now we need to check whether any conditions given for lambda. Okay, here we know this part is a positive number, this also a positive number, right? So definitely lambda cannot be negative, right? If lambda is negative, this becomes a negative number. So you need to write, since real part of z is greater than 0 and imaginary part of z is greater than 0, therefore lambda is also greater than 0. So take only the positive number. Lambda is equal to 3 plus square root of 17, because 3 minus square root of 17 is a negative number. That's all. Question number 10, the last question. Prove by induction that for n belongs to set of positive integers, this power n is equal to this. So for prove by induction, we need to prove it for n is equal to 1 first. For n is equal to 1, let's find the left hand side of this equation. Power 1 is the same, right? Now let's find the right hand side of the equation. Here replace n by 1. So 3 power 1 minus 1, 2 times 1 plus 3 minus 1, 4 times 1, 3 minus 2 times 1. 3 power 0 is 1. So you're going to get 5 minus 1, 4, 1. LHS is equal to RHS, right? That means the statement is true when n is equal to 1. And then we have to assume the statement is true for n is equal to k, and then we need to prove it for k plus 1. That's how the prove by induction works, right? So then you write, assume that for n is equal to k, we are gonna assume the statement is already true when n is equal to k. So 5 minus 1, 4, 1 to the power k is 3 power k minus 1, 2k plus 3, 4k minus k, 3 minus 2k. So we assume that it's already true. Now we are going to prove it for k plus 1 now. Okay, we need to prove this for k plus 1. So write for n is equal to k plus 1. Take the left hand side of the equation. LHS is equal to 5 minus 1, 4, 1 to the power k plus 1. Do not write equal to this because that's what we are trying to prove. Split it into 2. 5 minus 4, 1 power k. 5 minus 4, 1, 5 minus 1, 4, 1 power 1. And in the previous part, we have assumed that this is equal to, if you look at the previous part, this is equal to this, right? So make use of it, use of this result here. So this can be written as 3 power k minus 1 and then 2k plus 3 minus k, 4k, 3 minus 2k. That's the result for this. And then the next one, write it as it is. And then just apply the matrix multiplication here by keeping the 3 power k minus 1 outside. It should be, k minus 1 outside. So take the first row, multiply by the first column. It's going to be 5 times 2k plus 3 minus 4k. Now multiply by the second column. So we'll get minus 2k minus 3 minus k. And then do the same thing with the second row on first column. Just matrix multiplication. 4k times 5 is 20k plus 4 times 3 minus 2k. And then multiply by the second column. It's minus 4k plus 3 minus 2k. Now let's simplify this. Okay, we are at this step. I'm going to simplify it. 3 to the power k minus 1. When you open the bracket, 10k minus 4k is 6k plus 3. This will be minus 3k minus 3. And then 20 minus 8 is 12k plus 12. Minus 6k, 3 minus 6k. Right? I'm going to take 3 as a common factor because every term is divisible by 3. So when I take 3 as a common factor, I will have 3 power 1 here. This becomes 2k plus 1. Wait, did I miss something? It was 15 when I opened the bracket. Why I put 3 here? It was 15, right? So 2k plus 5. And then minus k minus 1. 4k plus 4. Minus 2k plus 1. Okay. Now, I need to write this in this format where we need to have n plus k plus 1 in the place of n. So 3 power, it becomes k, right? Plus 1 minus 1 will be cancelled, but still I'm going to write it as k plus 1 minus 1. And then 2k plus 5, right? I can write it as 2 times k plus 1 plus 3, which is 2k plus 5. And then minus of k plus 1. I'm writing everything, every element in terms of k plus 1. 4 times k plus 1. This will be I can write it as 3 minus 2 times k plus 1. If you ask me how do I know that, just look at this element. Replace n by k plus 1. Even if you open the bracket, you will get this term. So I have written everything in terms of k plus 1. If you compare these two now, it's the same matrix. You have k plus 1 in the place of n. So we proved it for k plus 1 also already. And then you need to write the conclusion. The result is, therefore, the result is true for n is equal to 1. And if it's true for n is equal to k, then it's true for n is equal to k plus 1. Hence proved. That's all. Double I now. Prove by induction. Prove that this expression is divisible by 7. So same like before, we need to prove it for n is equal to 1. For n is equal to 1, f of 1 is 8 power 2 times 1 plus 1, 6 power 2 times 1 minus 1, which is 8 cube plus 6. 8 cube is 5112 plus 6. 518. It is divisible by 7, right? Yep. So 518 divided by 7 is 74. Therefore, divisible by 7. So we proved the statement is true for n is equal to 1. Now, second step, we are going to assume that it's true for n is equal to k. Assume that for n is equal to k, f of k is equal to 8 power 2k plus 1, 6 power 2k minus 1 is divisible by 7. We are going to assume that it's true for n is equal to k, and we need to prove it for k plus 1 now. So this is a function. Now, for n is equal to k plus 1, f of k plus 1 is equal to 8 to the power 2 times k plus 1 plus 1, 6 power 2 to the power 6 power 2 times k plus 1 minus 1. We know f of k is 8 power 2k plus 1, 6 power 2k minus 1, right? So we are going to write this whole thing in terms of f of k, or you can just simply subtract f of k, do that, or you don't need to subtract every time. In fact, I explained that in the previous question also, previous question paper. So we write this as 8 to the power, it's going to be 2k plus 3, right, when you open the bracket. So I'm going to write it as 2k plus 1 times 8 square. Why I'm writing this way? Because we are trying to write everything in terms of f of k. So we need 8 power 2k plus 1, 6 power 2k minus 1. Here, it's going to be 6 power 2k plus 2 minus 1. I'm going to write it as 2k minus 1 times 6 square, which is basically 64 8 power 2k plus 1, 64 times 36 times 6 power 2k minus 1. So if we have 64 here also, let's say this number is 64, we can take out 64 as a common factor. You have f of k. So if f of k is divisible by 7, definitely 64 times a number divisible by 7 is divisible by 7 eventually, right? But we don't have 64. So what I'm going to do, I'm going to change it to 64 now. I'm going to write it as 64 8 power 2, 64 times 8 power 2k plus 1 plus 64 times 6 power 2k minus. But only 36, consider this as x, okay? We have only 36x here. But I put 64x, so I need to subtract the rest of them, right? Subtract 32x. So when you simplify, no, not 32, it's supposed to be 28, I think. 28 plus 36 is 56, 64, correct? Yep, I copied everything here. Let me delete this whole thing. Okay, we don't need these lines. Okay, now f of k plus 1 is equal to 64. Take 64 as a common factor. You have 8 power 2k plus 1, 6 power 2k minus 1, minus 28 times 6 power 2k minus 1, which is 64 f of k minus 28 times 6 power 2k minus 1. This is divisible by 7 and this is also divisible by 7 because 7 fours are 28, right? So when you add two numbers which are divisible by 7, when you add or subtract them, you are going to get a number which is going to be divisible by 7. For example, let's say 49 is divisible by 7. 14 is divisible by 7. When you subtract, you are going to get 35, which is also divisible by 7, right? So you need to write the conclusion here. Therefore, divisible f of x is, f of k plus 1 is divisible by 7. That's not the conclusion. So you need to write the conclusion this way. You have to write the result is true for n is equal to 1, and if it's true for n is equal to k, then it's true for n is equal to k plus 1, right? Therefore, f of n is equal to 8 power 2n plus 1, 6 power 2n minus 1 is divisible by 7 for all. This is a symbol for all, or you can just write words for all. N belongs to z plus. That's the conclusion. You don't write the conclusion, you will lose a mark.